Hello everyone, my name is Ajay Medzi. I am pursuing final year of Aeronautical Engineering at Institute of Aeronautical Engineering, Hyderabad. And now, in this presentation, I am going to talk about trajectory clustering for arrival aircraft via new trajectory representation. Yeah, without any delay, let's get started. Now, we will start with the introduction part of our presentation. Trajectory clustering for arrival aircraft is a topic within the field of aviation and air traffic management that focuses on grouping and analyzing flight paths of incoming aircraft as they approach their destination airports. The primary objective is to identify common patterns and behaviors among these trajectories, which can help improve air traffic control, airport operations, and overall flight efficiency. By clustering arrival trajectories, we can gain insights into factors like congestion, fuel efficiency, and airspace utilization, ultimately leading to more efficient and safer travel. This research area aims to enhance the management and optimization of aircraft arrivals, contributing to a more sustainable, and reliable air transportation. Importance of air traffic management and optimization. Safety. Ensuring the safety of passengers and aircraft is paramount. Effective air traffic management helps prevent collisions, maintains a safe separation between aircraft, and minimizes the risk of accidents. Efficiency. Optimized air traffic management reduces delays, which is essential for both airlines and passengers. It helps flights depart and arrive on time, improving the overall travel experience. Environmental impact. Efficient air traffic management reduces fuel consumption and greenhouse gases emissions. By minimizing unnecessary delays and optimizing routes, the aviation industry can contribute to environmental sustainability. Capacity utilization. Airports and airspace are finite resources. Optimized management maximizes the use of these resources, allowing for more flights to operate safely and efficiently. Economic benefits. Effective air traffic management supports the aviation industry's growth, which has significant economic implication. It creates jobs, stimulates tourism and business travel, and fosters economic development. Congestion mitigation. Major airports often face congestion challenges. Efficient air traffic management helps alleviate congestion by coordinating arrivals and departures, reducing the need for holding patterns and improving overall airport operations. Noise reduction. By optimizing flight paths and schedules, air traffic management can help mitigate the impact of aircraft noise on local communities, contributing to better quality of life for residents near airports. International cooperation. In an increasingly interconnected world, efficient air traffic management requires international cooperation and coordination. Harmonized procedures and standards facilitate global air travel. Methods for trajectory analysis and clustering. Several existing methods are commonly used for trajectory analysis and clustering in the context of aviation and air traffic management. Here are some of the key approaches. K-means clustering. K-means is a widely used clustering algorithm that partitions data into K clusters based on similarity. In trajectory analysis, each trajectory is treated as a data point, and K-means groups similar trajectories together. Density based spatial clustering of application with noise. DB-scan is another clustering algorithm that is particularly effective at identifying clusters of various shapes and densities. It can be used to discover trajectory clusters without requiring a predefined number of clusters. Hierarchical clustering. Hierarchical clustering builds a tree like structure of different clusters, allowing for different levels of granularity in grouping trajectories. It can be used to explore trajectory clusters at multiple scales. Gaussian mixture models. GMM is a probabilistic model that assumes data points are generated from a mixture of multiple Gaussian distributions. It can be applied to trajectory data to identify underlying patterns and clusters. Dynamic time wrapping. Dynamic DTW is a technique for measuring the similarity between two sequences that may vary in time or speed. It is useful for comparing and clustering trajectories with different durations or shapes. Principal component analysis. PCA is dimensionality reduction technique that can be used to extract the most significant features from trajectory data. Reduced dimension data can then be clustered more effectively. Hidden Markov models. HMMs are used to model time series data, making them suitable for trajectory analysis. They can capture underlying states and transitions in aircraft trajectories. Self-organizing maps. SOM is an unsupervised learning technique that can be applied to cluster and visualize high dimensional data, including trajectory data. It helps patterns and similarities in trajectory. Data collection. Conclusion. Improved clustering accuracy. Our new trajectory representation has been proven to enhance the accuracy of trajectory clustering for arrival aircraft by capturing essential information while reducing noise. It enables more precise categorization of incoming flights, enhanced predictive models. The refined trajectory data has allowed us to build more robust predictive models for aircraft arrival, which can be invaluable for optimizing air traffic flow and minimizing delays. Reduction in congestion. By clustering aircraft trajectories more effectively, we can better manage airspace and runway allocation, thus reducing congestion at airports during peak hours. Increased safety. The improved clustering method can contribute to a safer aviation environment by reducing the risk of conflicts and enhancing collision avoidance system. Data driven insights. Our research has a lot provided valuable insights into the behavior and patterns of arrival aircraft, which can inform future airspace management strategies and policies. Scalability and practicality. The proposed trajectory representation method is not only effective but also scalable and practical for implementation in real world air traffic management. Thanks for watching.